I've got a good one, Tom. How do you keep from getting breakdown in your casting, especially at the thin spots?
That is a problem that everyone has to address if they want a good part. Well, we built 3D parts to cast them in order to be exact, to get the left and the right side perfect. Unlike doing things by hand, where left and right might vary a little bit. You know, my hand shakes, so, you know, the right side's not going to look like the left side. So we have the advantage of the CAD programming in order to help us with that. However, I must show you that the distances, the tolerances needed to build a part, the tolerances needed to cast a part have to be in your mind when you're creating a CAD ring or a CAD part, whatever it is. If we take these two prongs here and we measure the distance between them, the distance is not even 1/10 of a millimeter. That's too small. That is not even the thickness of a piece of copy paper. However, when you go to cast it, the investment will go in there between, and then when we go to put gold or silver or whatever precious metal you're going to cast it in, it will break away, float around, and cause porosity, and then the casting's lost. So all that work up to that point will be gone. It has to be done again. So you lose 2 days, sometimes 3 days. You know, if this was done correctly, if your tolerance between the prongs was, let's say, 1/2 millimeter, or if it was on the bottom 0.1 as it tapered up, if you make that tapered prong, okay, give it that drafting that is needed, then as it comes up, it becomes heavier. Now it's going to hold it, because that's an opposing pyramid that's going to hold that and not let it flake off. That's one thing that you can do to help your project get along faster.
Well, that's great. But what about issues in other areas, like galleries?
You're talking about knife edges and not being filleted. The other things you have to consider is in CAD, you could do things extremely sharp, where in the real world, it doesn't work. For instance, we have this gallery here. If we'll go to our front viewport, and it comes down to a knife edge. Well, the knife edge looks good, but it's not practical, because even if you move up, let's say about 1 millimeter from there, and we take a measurement on this. Okay, let's take a measurement on this. Alrighty, let's go here. That's 2/10 of a millimeter, and I'm about 1 millimeter up to this area right here. Let's see if I can get a dimension, a line dimension. 1, 2. No, it won't. Let me see if it'll show it. There we go. So you see, it's 0.25 right at this area right there, and we're more than 1 millimeter up. The way to solve this problem quickly is to radius the inside, like we have here. You'll notice the difference as we bring it up here, and these are the same string, the same shank. However, at this point, I've radiused it, giving it a way not to fill it in with that very, very, very thin piece of investment, besides the fact you won't be able to clean it, and you won't even be able to get a saw blade through there. So it's not necessary. It's better if you have some kind of radius to help the build and to help the casting.
So in summary, we covered casting tolerances between prongs and sharp interior angles that finish in a knife edge.
Hi guys, thanks for watching. Please look for other videos in this series and learn how to
Perfect your trade.